Welcome to the fourth lecture of the course Python Programming for Beginners. In this lecture, we'll learn about the functions and models. In this lecture, we'll learn how to write Python functions, how to organize your source code into models. I think this lecture is the most important because you have to combine all the things you have learned in the previous lectures. So before moving on to this lecture, I strongly recommend you to do a review about everything, including basic types, basic syntax, variables and operators, and collection types, and even how to write decision making with if statement, and how to write loops in Python with for statement and while statement. If you are clear about everything, so let's move on. The first thing I'd like to talk about is a function. In Python, a function is a group of related statements that takes arguments as input, then performs a specific task in order to return expected output. Function provide better modularity for your application and a high degree of code reusing. As our program goes larger and larger, functions make it more organized and manageable. Furthermore, it avoids repetition and makes the code reusable. So here the syntax of defining a function. The function block begins with the keyword def, followed by the function name and parentheses. And an input parameter or arguments should be placed within the parentheses. The code block within every function start with the colon and is indented. The return statements exist a function optionally passing back an expression to where you call the function. The return statement is optional. That means your functions may not return anything, or may return something or may not return anything. So here I would like to give you an example. Here you have the print item function. You define def, the keyword def, and then followed by the function name, and then the input parameters. Okay, here I'm sorry, the collection here should have the s, the collections, not the collection. So inside the function, your code must be indented, something like indented, something like that, in the same indent. So here you have the for statement. So you loop over the collection. For each item, you print out the item is the item, and then the return statement here is optional. So after that, you can call the function. And okay, let me do the coding in the Python. So let's say def the print items collections, and then you do the for statement in the collections, and you print out the item is item. Okay, put a colon here, it's a string, and then here the return, you can omit it, you don't need the return, it's okay. So you have the function here, and then you can call it like you define a fruit list. For example, fruit list here equal to apple, orange, and lemon, right? This is a list, right? Then you call the function using the name, print items, and you put inside the parameter. Here is a collection, which here we input the fruit list. Okay, and then you see that it will work with print out all the items here in the list, and you can try with the set. Like here you can change to curly bracket, and it's your set, and then you can even clone with the set. You will see the same thing, but here is in a different order, right? Because it's a set. So similarly with the tuple, it's the same thing you can do yourself. So here you can see that we can reuse a function many times and even with different inputs and data types. So that is the way how we reuse code. It's very convenient. So next thing I would like to talk about is the scope of variables. The scope of a variable determines the portion of the program where you can access a particular identifier. There are two basic scopes of variables in Python, global and local. Variables that are defined inside a function body have a local scope, and those defined outside have a global scope. This means that the local variable can be accessed only inside the function in which they are declared, whereas global variables can be accessed throughout the program body and by all other functions. When you call a function, the variables declared inside it are brought into scope. So, for example, here I have the file, so source of file scope.py. So let's see, here we have the total is a global variable and we set it to 0, and we define a function here which sum two number, and we add it into a total and return the total to the caller. So here you say the total is a global variable, so total here is inside the function, so here is local variable. So let's say when we execute the code, okay, so I will use Python scope.py, and then we should see here the inside the function, the total is the total of 10 and 20. So the total here is 30 inside the function. But here outside the function, the global total is the same. It is actually 0 because it what we do inside the function here doesn't change the total here. Okay. So there is no way to access a local scope from the global scope. That means from this scope, you cannot change the member of the function, the variable defined locally in the function. If you want to reference a variable in a function to global scope, you specify with the global keyword. So I will show you the code here, the scope 2. You will see this code is a bit different. So we have the same global variable total and the same function here, but inside the function I have this line. This is global total. So this line indicates that the total variable here refers to the global variable here. So what I change here inside the function will also change the global variable here. So when you call the sum function with 10 and 20, it's compute the sum and it set the total into 30, sorry. So then when we print out the outside function here, we can see the total is 30. So we can try it here, scope 2.py, right? And then you will see the inside the function here is 30 and outside also is 30. Okay, so here you see that the line here, global total, this is how we tell Python that you want to use a variable in global scope. Accordingly, you change to this variable. You change the variables, also change the actual value of the variable in the global scope. Okay, So the next thing I would like to talk about the function arguments. So Python provides three types of arguments: required arguments, keyword arguments, and default arguments. Let's consider an example in Python. So here I open the IPython and we consider an example. How to say, we define a function which prints out the name and age of a person. So we have the def print info name and age. We have two parameters, right? And we should have a colon here, and inside the function we just print out the name and the name here, and we print out the age okay. So that we have the function. Here we can say that the name and the age are required arguments. So required arguments is an argument passed to a function in correct positional order. Here the number of arguments in the function call should match exactly with the function definition. So when you call the print-info function, you have to provide the parameter in exact order as defined. So for example, like we have the print-info John and 20 years old, for example. So you will see here the name and the age. If you place if you place the arguments here in different order, you will see unexpected outcome. So for example, I put the 20 before the name. So here you see that the name is 20 and age is shown is unexpected, right? So the next thing is the keyword argument. Python also can, Python can can use the name of variables defined in the parameter to identify the input. Here you don't have to remember the order of argument, and you can specify each parameter using its name. So let's say we have the same example here, and you can do the print info, but here you specify the name is John and the age is 20, and it's correct. And even you swap the order here, so you put 8 first and you will see the same result, right? That's called the keyword argument. So keyword argument is an argument related to the function calls. So when you use the keyword arguments in the function call, the caller identifies the arguments by the parameter name. So yeah, the final thing is a default arguments. A default argument is an argument that assumes a default value is if a value is not provided in the function call for that argument. So let's say when you define a function here, you want to set the age default to 20, for example. So then you just change the function definition to age equal to 20 on this line. And then when you call the function, say you call the print John 20, right? You will see the same thing, but here you don't need, you can omit the 20 here, you will see the same thing, because now if you don't provide the number here, the Python understand that this is 20 by the default keyword here. So if you can see with the different number here, it can change to any other number. Okay. Let's move on to the next recursions. Python also accepts function recursion. So recursions mean a defined function can call itself while it's executing. This means that the function will continue to call itself and repeat its behavior until some condition is met to return a result. The following example is a recursive function which computes the sum of the first n integer. You can see here the sum integer, and inside the function you check the number n, which is a parameter here, is smaller than 1, then you return 0, and then else. If not, you return the n plus itself, the function itself. We call the function with the n minus 1. So that's called the recursive version of the sum function. And you can do the same thing with the loop, the for loop, right? You don't need the recursion here. You can check the same thing. If n smaller than 1, return 0, and then you set the sum to the variable to compute the sum. Then you will do the loop over the rank from 0 to n, and to sum all the number here to the sum function, to the sum variable, and return it. So these two functions are the same, but here you have the way how to write the recursive function. So let's say I have the file here, so we can check the recursion.py is exactly what we see here, the function in this file, right? So let me open the non-recursion version here. Okay, you can see the recursion and the non-recursion. So you see here it's exactly in the slide, and I try to execute it, so I will use Python instead of IPython. So Python, we execute the recursion first, so recursion.py. So we see, so you see here the result is 0, 1, and 55 for the inputs, 0, 1, and 10. And we execute the non-recursion version, and we also see the same result here, the same result. Okay, so that is about the function recursion. To sum up, function is very important in Python, that I can say you will work on it all the time you do programming. At this time, please make sure that you know how to define a function and how to call it correctly.